So dear students, in the last video we discussed about Warner's theory of coordination compounds. This theory suffers a lot of limitations, but before going to discuss these limitations, first we have to learn the nomenclature of coordination compounds, naming of coordination compounds according to IUPAC norms. So first I will tell you the points regarding how to name according to the rule of IUPAC system, and then we will take some examples. So let us start. The first point regarding the naming of coordination compounds is cationic part is named first, followed by anionic part. This is just like for a simple salt, sodium chloride, NaCl. So sodium is cationic part, chloride is anionic part. We name it as sodium chloride. First cationic part, then anionic part. Similarly, if a coordination compound has cationic and anionic both the parts, then we will first name the cationic part followed by anionic part. For example, AgCl whole twice Cl. Sorry, NH3, not Cl. NH3. So this part is cationic part and this is counter and anionic part. So name of this compound part will be given first, followed by this counter ion, that is the chloride. जो पॉजिटिवली चार्ज पार्ट है उसका नाम पहले दिया जाएगा और जो नेगेटिवली चार्ज पार्ट है उसका नाम बाद में लिया जाएगा. Second point, in the complex ion, ligands are named first. For example, this ammonia is named as amine and it will be named first. Then this silver as per the rule. Other example, K4 FeCl whole 6. Cationic part is potassium and this is the anionic part. So this will be named first, followed by the name of this ion, which is anionic. Why naming this part? This is ligand. It will be named first, followed by the name of the metal. If a compound has many ligands, 2 or more than 2, then they are named in alphabetical order. For example, CO, NH3 whole 4, H2O, Cl, Cl2. So this compound, as you see, has 3 different types of ligands. In alphabetical order, amine comes first. Ammonia is named as amine. NH3, this is neutral ligand, and in IUPAC system it is named as AMINE, amine. Water it is named as aqua, AQUA, aqua. And anionic ligands are ligand by adding O as suffix in their names. This chloride is named as chlorido or chlorito. O is added. Now see here, A, both have A, but M comes before Q in the alphabetical order. Therefore, amine will be named first, then aqua, and then chlorido. This will be the order of naming the ligands. Now next, third point. If same ligand has many molecules or many anions, for example here, same ligand, ammonia, there are 4 molecules of ammonia. Therefore, tetra will be used before amine. So it will be tetramine. If there are 3 molecules of ammonia, it will be triamine. If there are 2 molecules of ammonia, it will be diamine. तो जितने किसी इंडिविजुअल लिगेंड के आयंस या मॉलिक्यूल्स होंगे, अकॉर्डिंग टू दैट प्रीफिक्स डाई, ट्राई, टेट्रा will be added to their names. Right? Now, very important point. If the name of a ligand carries di, tri, tetra, etc., then bis, tris, tetrakis are used, and then the name is written in parenthesis. This is very important point. For example, COEN whole twice Cl2 Cl. This is the compound. So you know that it is the abbreviation of ethane 1,2-diamine. I have told you in the previous video. En is the abbreviation of ethylene diamine or ethane 1,2-diamine. So ethane 1,2-diamine, in the name di is used. Therefore, while naming, before writing 1 ethane 1,2-diamine, bis will be used. So I am only writing the name of this ligand. It will be written as bis, B-I-S, bis, and now ethane 1, 2 di A-M-M-I-N-E. If there is word tri, then tris will be used. If the name carries word tetra, then tetrakis will be used. So this is very important point. Now, fourth point. This is also very important point. Name of the metal, if it is a part of cationic cationic part, if metal is present in the cationic part, then it is named as such, as the element. For example, it is cobalt, so it will be written as cobalt, followed by the oxidation number. Here, this is cationic part and metal is center metal ion is present in cationic part. It will be simply silver, right? So if center metal atom or ion is present in the cationic part or in the neutral molecule, then it is named as the element. Cobalt, chromium, and so on, silver, and so on. But if it is present in anionic part, then suffix 8, A-T-E, 8 is added in the name of the element. And then the oxidation state is written. Oxidation state is written in both the cases. Whether the central metal atom is present in anionic part, cationic part, or compound is neutral, oxidation state is written. But once again I am going to tell you that if the compound is neutral or the central metal atom or ion is present in the cationic part, then it will be simply named as the element. But if it is present in the anionic part of the coordination compound, then suffix 8 is added. To this compound, the metal central metal atom ion will be named as cobaltate. Cobalt, and then 8 will be added to cobaltate. Cobalt plus 8. Cobaltate. Silver. Here it is cationic part. It is the anionic part. So here it will be written as cobalt, simply cobalt, not cobaltate. I'm sorry. Simply cobalt. In the anionic part, the name will be 8. This is the right example. Potassium is the cationic part and coordination sphere is the anionic part. So here the metal will be named as ferrate, F-E-R-R-A-T-E, ferrate, followed by the oxidation number, which is 2, ferrate second. Potassium hexacyanidopherrate second. This will be the complete name of this compound. Here it is present in the cationic part, therefore the name will be cobalt third. Cobalt, right? Now we will take some examples to explain the norms. CO sorry. Let us explain the name of this compound. This compound has two parts. This is cationic part and this is anionic part. The cationic part is named first. Therefore, complex ion will be named first. While naming cationic part, first we name the ligands, and the ligands are named as in the alphabetical order. So this is amine and this is chloride. A comes before C in alphabetical order. Therefore, amine will be named first. Now there are 6 molecules of ammonia. Therefore, hexa, 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 AMMINE, hexamine. Now, chloride, there are 2 ions, therefore di and O is added in the anionic ligand to dichlorido or chlorido. Now, center metal ion will be named. It is cationic part, therefore it will be named as such cobalt. Cobalt. And now oxidation state. 2 ions which have coordinated with cobalt, and this is counter ion which has only ionic bond with cobalt. So 3 units of negative charge, therefore its oxidation state is 3rd. So the name of this compound is hexamine dichlorido cobalt 3rd. Other example, K3 Fe whole 6. This compound also has cationic as well as anionic part. Cationic part is named first, and our cation is potassium, so it will be named as potassium. Now, anionic part, in the anionic part we name first the ligand, and the ligand is cyanide, O is added. Therefore, and the number of the cyanide ions is 6 to hexa, cyanido. Now, in the last center metal ion will be named. It is ferrate, and the oxidation state is 3. Therefore, 3rd. The name of the compound is potassium hexacyanido ferrate 3rd. Note down. Yes. Now see this compound. The compound also has 2 parts, cationic part and anionic part. So first we will name the cationic part, and in the cationic part the ligand is named first. Here our ligand is ethane 1,2-diol, ethane 1,2-diol, and there are 3 molecules of the ligand, and the name carries di. Therefore, it will be started with tris. Tris, T-R-I-S, tris, parenthesis, ethane, one, two, diamine, Now the central petal ion, it is cobalt and it is today present in the cationic part, therefore it is named as such, cobalt. State, its state is third. And now anionic part, sulfate. So this is the full name of this compound. A question for you, and you send this question on WhatsApp. Answer of the question. Note down the question. Write IUPAC names of the following number 1, CO, NH3 whole 3, Cl3, second NiCO, carbonyl, third NH3 whole twice, H2O, whole 4, H2O, NO2, Cl2. One more example. K4 Fe Cl whole 6. To send the answers through WhatsApp. Thank you.